Welcome to this video about encapsulation in C++. Encapsulation is a fundamental concept in object-oriented programming. It involves hiding implementation details and exposing interfaces to interact with objects. Let us delve deeper to understand the importance of encapsulation in C++. Encapsulation is the bundling of data and the methods that operate on that data within a single unit or class. It involves restricting direct access to some of the class's components, acting as a protective wrapper to prevent unintended modifications. Encapsulation facilitates hiding the implementation details of a class, showing only the necessary interfaces to the outside world. Consider the diagram shown, where the outer circle represents the class, the inner circle represents the private data, and other smaller circles are public methods to access and modify the data. C++ provides access modifiers to control the visibility of class members, which plays a vital role in encapsulation. The first access modifier is private. Private members are accessible only from within the same class. The second access modifier is protected. Protected members are accessible from within the same class and any derived classes. And the third one is public. Public members are accessible from anywhere. By default, if you do not specify any access modifier, the members are private within a class. Take a look at the code snippet shown on the left. Getters and setters are methods used to access and modify private data members of a class, providing a controlled interface for interacting with the class's internal state. Getters are methods that retrieve the values of private data members, allowing external access to the class's data in a controlled manner. Setters are methods that modify the values of private data members, providing a way to update the class's data while encapsulating any necessary validation or logic. As seen in the code snippet, setters allow validation before changing the data. Encapsulation offers several benefits in software development. First, data hiding prevents unauthorized access to sensitive information, protecting the integrity of the object's state. Second, data validation ensures that the data stored within the object remains consistent and valid. Third, implementation can change without affecting the interface, allowing for greater flexibility and maintainability. Fourth, it reduces complexity by bundling related functionality together, making the code easier to understand and manage. Finally, encapsulation improves maintainability and reusability by creating modular, self-contained components. Have a look at the code snippet given. It provides controlled access and modification to the radius of a circle class. To implement encapsulation effectively, it's common to separate the class declaration from its implementation. The header file with the .h extension declares the interface of the class, including the data members and method signatures. As shown, private data members are hidden from external access. Public methods provide a controlled way to interact with the class. Implementation details are separated from the interface, allowing for flexibility and maintainability. Users only need to know how to use the interface without needing to understand the underlying implementation. The implementation file with the .cpp extension contains the actual code that defines the behavior of the class methods. The implementation can change without affecting users of the class, as long as the public interface remains the same. Internal calculations and logic are hidden within the implementation file, protecting the class's internal workings. Users only see the public interface, interacting with the class through its methods. Separation of concerns improves maintainability, as changes to the implementation do not require changes to the interface. When using an encapsulated class, users only interact with the public interface, accessing the class's data and functionality through its methods. Implementation details are hidden from the user, protecting the class's internal state. Direct access to private data is prevented, ensuring data integrity and consistency. Implementation can change without affecting user code, as long as the public interface remains the same. Encapsulation creates a clean, usable API that simplifies interaction with the class, as shown in the code snippet. Here are some best practices to keep in mind when implementing encapsulation in C++. Always declare data members as private to prevent direct access from outside the class. Expose only what's necessary for users to interact with your class through the public interface. Use setter methods to validate data before changing internal state, ensuring data integrity. Use header files to declare the interface and implementation files for the details of the class. Mark methods that do not modify object state as const to enforce immutability. Each class should have a single purpose and encapsulate only related functionality, promoting modularity and maintainability. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.